Hi, friends. Welcome to another episode of Beyond the Clouds Edge to Edge Transformation. I'm your host, Shankar Hemadi of Blue Horizons. And it's always a delight to talk to people with very interesting perspectives. One of them is Kelvin Low. I met Kelvin over the past 2 years at various conferences, and he was the tallest guy around, so it was easy to spot him. And then I found out about the variety of things he's done besides being tall in a variety of different spaces and many different geos around the world. So Kelvin, tell us a little bit about you and how you got to be at SemiFive and everything.
Sure. Shankar, always a pleasure to see you. All right. So a quick history about me. I started my career in Singapore, a little island there. And at that time, there's a little foundry called Chartered Semiconductors where I joined after school. Believe it or not, I actually worked in a fab for a good 6-7 years. Wore the bunny suit, look at the wafers, measure the wafers. So, but I figured out, hey, the engineers are working really hard. Many a times, the business outcome may or may not be as successful. I decided to venture into the business side of Foundry. So I moved on to product marketing. And at that time, Chartered Semiconductors actually partnered with IBM and Samsung. There was a common platform, if some of you may recall, there's many years ago. So I led the common platform marketing team for a bit. So after Chartered, Global Foundries acquired Chartered, that was when I moved from Singapore to the US. And that's about 13 years now. Okay, continued with the Global Foundries for a bit, and then I decided to move on to Samsung Foundry. Spent a good 4 years plus there, managing the marketing for FinFET as well as ecosystem expansion. And decided to take a break from Foundry. I joined ARM as the VP of Physical IP Marketing and Licensing. At ARM, I learned a great deal about IP business, not exactly the same as Foundry. And then after ARM, I did a short stint in SMIC. I spent a lot of time in Shanghai, actually. I led both overseas marketing as well as sales. And next in my career, I decided to, hey, I should try a startup, right? I'm in Silicon Valley, timing is great. So that's where I landed in SemiFive, and I've been here for about 3 years now. It's definitely a different industry, coming from the wafer fabrication side of the semiconductor supply chain to IP to ASIC. I'm not sure I'm moving up the food chain or moving down, but definitely moving somewhere in the food chain. But definitely a lot to learn. Different parts of the food chain obviously is also giving or playing a critical role in creating value and adding value, right?
No wonder we had so many conversations. What role do design services company have in strengthening the supply chain? As you know, the global supply chain has been quite a mess from the pandemic days, and now with this tremendous force towards AI and generative AI, I think we are up for another supply chain challenge. So how can companies like yours help?
Well, great question on supply chain. I'm not sure whether design services company like us have direct impact to the supply chain per se, but what we are doing is we are actually trying to make custom silicon or domain-specific, chips available to more and being more accessible. What we mean by that is really to make it easier to do chip design at the right cost point and at a faster pace, right? Because all of this is important. Time to market is essential. So the role we play, I would say, is we're allowing more players to come in with great ideas, all right? I think it's important to have a multi-company supplying, let's say, if you talk about AI chips, to have some diversity in the number of players there. Competition is always healthy in any space, right? I think from that, we can actually maybe allow then more innovators to basically introduce a solution, and then for the end customers, have more options for them to choose from, right? That from that angle, we could ease maybe the supply chain, where then the end adopters will have more options to choose from rather than from one or two dominant players. Yeah. So we play that critical role. I call it small but extremely critical, because without design houses, many of these companies who have great ideas, some IPs, they are not able to take off, right? So we are allowing them to take off, and then from there for them to proceed with their journey. Yeah.
And for the longest time in the semiconductor industry, we're used to CPUs and maybe GPUs and peripherals. Things seem to be changing quite rapidly. What role do you see? I mean, do you think application-specific processors or bespoke silicon is here to grow? What is happening there?
Yeah, in fact, this is not new. Another super question, Shankar. So many may think that ASIC is new, is a new wave. Obviously not true. ASIC has been around for the longest time. I think what's coming is they are coming in waves, depending on the application and the use cases that exist today. So obviously in the course of being the general manager of SemiFive US here, I've talked to many customers and potential customers and partners. What we're seeing is, yes, I think GPUs, CPUs are great for certain functions, but there's a huge appetite now from the various part of, let's say, the semiconductor players, including the set makers and OEMs, where they feel that, okay, there's still a need to have more specialized silicon, right? I think the obvious, very successful story is, I would quote maybe Apple, right? Moving, from using the SSPs into in-house silicon, and they're pretty much fully migrated all their products to now in-house silicon, right? Or Apple silicon, as they call it. And why so? If your solution has, let's say, vertical stack, you own the software, you own the hardware, and even better, if you own the end product, I think it makes perfect sense to have bespoke silicon or domain-specific silicon, right? In the automotive space, I think what we're also hearing is many of these electric EVs are starting to use, let's say, off-the-shelf solutions, GPU-based, but they're telling us that, hey, number one, obviously it's expensive. Number two is there's a lot of overhead that they don't need in the specific use case of their electronic vehicle or the electric vehicle. So they're considering to basically then doing their own chips, more specialized functions, stripping out, redundant functions that they think is they're paying some overhead and that's just not needed for their application. Yeah. So I think this is really the best time. The big wave in AI, the big wave in automotive. I think this will basically give a lot of boost to many of these ASIC design houses like us. Yeah.
Yeah, I mean, I think this is the best time to be in the industry. I came out of my virtual retirement for some time to come back because there's so much to do. Speaking of which, hybrid technologies, hybrid architectures are becoming popular. We saw that new alliance between Intel and ARM and all the SoftBank. Do you see a big shift from CPUs that are based on one architecture or the other, x86 ARM and RISC-V? What's happening over there, and how will it contribute to the growth of the industry?
Yeah, okay, yeah, definitely. Short answer is definitely yes. Many have kind of seen I would say the huge a couple years ago, the huge battle between RISC-V and ARM, and saying that one architecture is going to replace the other. My personal view is there's no replacement that's going to happen. I think there's going to be a lot of complementary functions. Multi CPU ISA will coexist. We're starting to see SoCs actually designed that way because taking just ARM and RISC-V for example, I think they're optimized in different ways, right? And they play a role on the SoC, right? But of course, in terms of the I call it the marketing drive. There's going to be a lot of narrative around one architecture being better than the other. But I view it as from a different angle. I think both architectures are important. Optimized correctly, they will play a very good functions on an SoC itself. Yeah. So relevant to, let's say, maybe what SemiFive does. I think there was a notion that SemiFive only does RISC-V architecture chips. Entirely not true. We service what the customer needs. I think that's the most important, right? If they need an ARM-based architecture for their reasons, we'll service that. And conversely, if they need a RISC-V based architecture for their specific design point, we will service that too. There are customers asking us to kind of integrate both even, and that's also possible. Yeah.
But what about the challenges with these chiplets, the power budgeting, the EMR, packaging issues?
Okay.
How do you deal with that as a service provider?
Okay, so let's focus on chiplets. Definitely a big drive as well for the industry with Moore's law. Some claim Moore's law has kind of stopped. Some claim Moore's law has slowed down significantly, right? So that's obviously driving the emergence of chiplet in many forms. I think technical-wise, industry, it's good to see the industry trying to align on a common standard, especially the die-to-die interface, whether it's UCIe and previously bunch of wires and other short-range SerDes. While we were investigating, and I was also personally looking into SerDes quite a bit, I think a lot of the challenges are beyond the technical aspect right now. I think the business model is still long ways to be ironed out. Vertically integrated companies are able to basically manage the whole components and different issues internally within one company. Once you deal with multi-company supply chain in chiplets, there's still going to be some discussions and agreement and alignment needed, especially in the business model, right? And Shankar, you talk about also, things like, heat dissipation challenges once you assemble all the different dies or all the different chiplets. That part is also still requires quite a bit of optimization. But the good thing is, there are companies now beyond the large guys like whether AMD, NVIDIA, or Intel. Smaller guys, smaller startups are trying to drive towards chiplets, and we're seeing huge progress. So I think we're trying to enable some of this, and then taking some reasonable baby steps in the business model where we can make then the solution more generally available to the mass market. Yeah.
Wow, and it is really happening then.
It is.
Now that all this is happening simultaneously, you've got hardware that's shifting, you've got the cloud and the edge that's shifting, and then you've got generative AI and machine learning that's also shifting. What's the interplay between hardware and software and connectivity? And how do you, as a service provider, play in these things? Do you only do the chip, or how do you coordinate to make sure that the whole solution is successful?
Yeah, there's a very complex, I would say, formula that we're trying to manage, or complex problem that we were trying to solve with our customers too. So a number of the discussions that we had but in the early days is like, hey, Mr. Customer A, they'll come to us and say, hey, I have a great idea. I have a concept here. And in fact, I have a neural engine that I've really developed, and I think this will take off, right? However, being small, as you know, budget is always a constraint that we have to work with. They're going to invest a lot of the development resources and budget on software development, right? And that is the right thing to do, because in the AI space, although we talk a lot about hardware, it's also actually the software stack that enables the best solution for the total AI package, right? So we are allowing, let's say, innovators that to continue to invest in the hardware area, in the software area, I mean. And we come in, design houses like us come in, and we will help the companies translate maybe their ideas, taking their IP, their neural engine, and completing that onto a full SoC. Because if you look at an SoC, an AI SoC, the neural engine or the deep learning accelerator is a key component. Everything else around that is almost like a platform, if you will, right? If you plug another neural engine into the platform, you can realize a different chip, right? So that's a concept that we have adopted. We call it SoC platform, something we believe that is unique. Platform is not unique, but for SemiFive, we think SoC platform is a bit unique. And we allow the customers to continue to invest in software development. And we have a couple of customers that successfully launched a product. submitting benchmarks on ML perf, showing excellent results on silicon that we have delivered to them, right? So that's one component, but at times, design houses also will need some internal software capability. These are much lower level software capability, Shankar. More like, driver development, bringing up PCIe Gen 5, for example, right? Once the silicon is out. So to that extent, we will also have a software development team to basically develop drivers and Linux-based software so that we can showcase some of these high-speed interface at the board level. But it is a complex problem that we solve with every single customers. I'm not doing really justice by just describing it as if it's that easy. Yeah, it is not. Yeah.
So as much as it's exciting, it's challenging, and maybe that's what makes it exciting, huh?
Exactly.
To be an engineer today. Speaking of which, SemiFive, please tell me about its journey. It started off in Asia, and now through an acquisition, you're entrenched in the United States as well. Are you becoming a global company, and how do you manage all the complexities of being global in in these changing times?
Yeah, no, perfect. I think our company, vision is to be the new global hub of custom silicon. So the word global has already been built into the company since the formation. So we just turned 4 years old, Shankar, very recently. Companies started off in South Korea, headquartered in South Korea. When I joined about 3 years ago, we are only about 100 plus person company. So at that point, the CEO already saw the need and the vision to expand globally beyond Korea. In Korea, business-wise, we're doing very well. The most advanced node tape-out is at 4 nanometer today. So we've done a 4 nanometer tape-out, looking at the next node, looking at chiplets. And we have expanded into the US about 2 years ago, where we officially opened the US office. We have a very small team here. Throughout that journey, we also did a couple of acquisitions. We acquired 3 small design houses in Korea, and we did a first acquisition overseas, a company called Analog Bits. I think many of you know Analog Bits for their IP and for the wine, right? So the first question, and a little bit of joke aside, but the first question when we announced the acquisition of Analog Bits, many asked me, "Are you still going to maintain the wine?" I said, "Obviously, yes," right? So yes, so we Analog Bits now. We have a larger team in the US from a company-wide standpoint. They're based in Sunnyvale. Myself, I'm based in San Jose. And very recently, we just opened our China office very recently. So we're also tapping into that market. Obviously, that part of the world also has a lot of design activities. I need to have custom silicon support. So we're also exploring that. Yeah. So yeah, we're definitely going global. I did miss out another important element about the word global here. We do have design centers overseas as well. We have a team in Vietnam and also a team in Bangalore, India. So design centers are also global in this case. Yeah.
That's wonderful. And now that technology is moving so fast, are your design practices changing? Are you using any of that AI, ML, or generative AI capabilities as you designed new technologies?
Yeah, one of the charter for internal design teams is to increase efficiency, right? And the efficiency, as you know, equals cost and time on our side. The more efficient we can be, the more projects we can take on at one time. So there's a lot of obviously priority and focus right now on trying to leverage, machine learning, AI capabilities that already exist in some of the EDA tools, and to build that as part into our design methodology. So yes, I think, Shankar, definitely there's a huge focus and priority for our engineering teams on that front. Yeah. So definitely we'll be incorporating more of these elements into our design flow. Yeah.
The world is changing so fast. No one has a crystal ball. But through your vantage point and all the global experiences you have, where do you see the technology moving? Where do you think is the hottest technology, say 3 years from now, 5 years from now?
That's an interesting question. Like you said, I think no one has a view of the crystal ball. Um, I I anticipate, although I think many have talked about automotive, yeah, EVs and more silicon in electronic vehicles. I think just that is just the starting point, right? We're seeing a lot more EVs being introduced in the cars, but the innovation I think that will continue to take place in the future EVs is going to trigger some new, I would say, chip architectures, or to need to have even different solutions altogether. There's even talk about having chiplets in automotive chips, right? So that could be a different angle on, let's say, new use cases. AI obviously will continue its big trend up. What else? I think advanced packaging, an area that that has been heavily invested in many years ago. I think that will become even more critical, right? There's going to be many says that substrate basically is the new PCB, right? So that basically we need to rethink, overall how system design is done. Today is not throwing stuff over the wall, obviously. When you do a system architecture definition, you almost have to incorporate different parts of your toolbox that exist before you finalize your architecture, right? So I think advanced packaging will see a lot more advancement there in subsequent years. So the silicon technologies will always still push the limits, right? We can claim that now we are going into Armstrong's area, but I think the innovations all will take place in vertical stacking, right? How can you stack more functions vertically, whether it is NMOS stacking on PMOS or SRAM stacking on transistors or backside, power distribution techniques. So everything is kind of stacking up differently. So that will also, I think, result in more innovative silicon advancement, I think, ultimately. Yeah.
So Kelvin, you, like me, have worked in many different aspects of hardware and software, from the foundry to the design services, from engineering to marketing. What advice do you have for people looking for excitement in our careers? And how should they go about it? Is it easy?
Yes. I definitely saw, and every part of the supply chain is just a different, just totally different, right? What I will advise is, interest is important. I think starting point is you must love what you do. A basic starting point. I think it's very easy to say this, but it's extremely hard to embrace it, right? Because if you love what you do, whether it's technical or business or partnerships, you will do well, right? Uh, that's one. I think second is also knowledge. I think it's the wealth of knowledge out there. Never stop learning, never stop sharing as well. My principal philosophy on knowledge is the more you share, the more you get, right? So I think that's also extremely important. I'm starting to be more active in some of these incubator companies, like the likes of Silicon Catalyst, or Plug and Play, where there's an opportunity also to kind of give back, right, to the younger entrepreneurs, share your experience with them, make the industry really exciting again. I think there's a spot, or there was a concern where semiconductor / hardware industry is kind of fading off among the younger generations. Yeah, I think all of us have a part to play, and we can make this industry very exciting again. Yeah.
What role do you see organizations like Silicon Catalyst or Plug and Play playing in this? Uh, what kind of catalysis is needed to reinvigorate the industry to the point where we can meet the demand? The demand seems to be much higher today.
Mm. I think they're definitely enabling the early startups, to have the path towards a successful rollout according to their individual go-to-market plan, right? Whether it is through connecting and networking some of these startups with the right people in the industry, providing financial and technical support, whether it's through funding or whether to in-kind partnerships. I was extremely, I would say, motivated, to see companies like that, helping some of the smaller startups to take that necessary baby steps so that they have a chance even to launch their product eventually to the marketplace, right? Because without incubators or accelerators, I think many of these startups will never even take off beyond the ideas in the garage. Yeah, they will just stay as ideas in the garage. So very exciting to see that in future, SemiFive will also find a place where we can contribute to some of these incubators and accelerators. Yeah. Yeah.
Exciting. And I'm all for it because we need the same kind of momentum that our customers are feeling, or the pressure to innovate. And I'm so glad we're talking about all these things. We'll have to get you back on the show when SemiFive delivers on many of the promises and the things that you can talk about. Are there any technologies you can talk about today that you have been able to deliver? What particular sectors that you worked in?
Definitely we can. A number of success stories for our early customer engagements are actually in the AI area, which is the big word today, right? So we have success with customers that is doing text-to-speech recognition. So kind of basic stuff in the Edge AI enabled by FinFET silicon using our design technology. And then we have customers who are doing fast, high velocity trading and using AI, and also enabled by 5 nanometer technology using our platform, right? So those are the success stories. We even had a customer that was doing AI-enabled surveillance cameras, right? As you know, it's so important. Surveillance cameras are building in a lot of edge processing, image recognition, right? So that you can basically improve the speed and also reduce the burden of doing everything in the cloud, right? So those are the kind of applications that we have already completed silicon delivery. We are taking on board new applications, obviously. Keyword is still around AI and automotive. That's why we see a lot of appetite for more bespoke silicon or custom silicon. Yeah.
That's amazing. So AI could very well become automotive intelligence, huh? The way things are
I
going.
think so. I think so. The A fits perfectly well. Automotive intelligence. I like that. Yeah. That is, yeah.
Well, there's no end to how many things are happening, and I'm so excited, Kelvin, that we are talking shop. And for all those people listening, I would love to hear your ideas, what's happening from your vantage point. There's no one person who can look into the crystal ball. So we are always looking at new ways of, or new angles to the whole problem so that we can make meaningful, judicious predictions and better horses on how we can contribute. Thanks again, Kelvin, and I look forward to talking to you again when you have the next big thing coming besides AI and automotive and autonomous systems.
No, thank you. Thank you, Shankar, for the opportunity. I really appreciate it. Yeah.